Welcome to True Projects. In this video, we are going to explain about a project titled Machine Learning Based Aspect Level Sentiment Analysis for Amazon Products. So now coming to the introduction part, machine learning has become a powerful catalyst across different fields, fundamentally changing the way we glean valuable information from extensive datasets. A notable use of machine learning is in aspect level sentiment analysis, an advanced method for comprehending and interpreting sentiments conveyed in reviews. When applied to Amazon Products, a platform rich with diverse customer feedback, utilizing machine learning for aspect level sentiment analysis shows great potential. So now coming to the objective part for this project is to elevate the thoroughness and accuracy in comprehending customer sentiments as conveyed in reviews. While conventional sentiment analysis offers a general polarity score, aspect level sentiment analysis adopts a more detailed strategy by breaking down reviews into specific aspects or features of a product. This approach enables a nuanced understanding of the strengths and weaknesses of products, providing businesses with insights for targeted enhancements and optimization. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Seaborn for visualization are important. Second, here we have storing the dataset English text for analysis. So here in this, the dataset containing English text analysis data is examined to understand its structure, features and characteristics. Exploratory data analysis, that is EDA techniques, may be employed to gain insights into the distribution of data, identifying patterns and assessing the quality of information. Then here we have data processing, replacing the label. This involves pre-processing the data, and one specific task is replacing or encoding the labels. For instance, in sentiment analysis, labels might be transformed into numerical values to facilitate machine learning model training. Then we have visualization using Seaborn and Matplotlib. Visualization techniques utilizing Seaborn and Matplotlib are applied to present insights into the data. This may involve plotting the distribution of labels, creating a word cloud of textual data, or generating other relevant visualizations. Then next we have label encoding string to integer. The categorical labels in the dataset, typically represented as strings, are converted into numerical format through label encoding. This is often a crucial step for machine learning models to process and understand the data. Then next we have feature selection. So here in this feature selection, identifying and selecting relevant features from the dataset is crucial for building an effective model. This step involves choosing the most informative attributes that contribute significantly to the model's predictive power. Then we have count vectorizer, the sentence. In natural language processing, that is NLP task, transforming text data into numerical vectors is common. Count vectorization is one technique that converts a collection of text documents to a matrix of token counts. Next, here we have building the model. This stage involves constructing machine learning models. In this case, random forest, NiFi, support vector machine, that is SVM, and a voting classifier are being considered. Each model has its strength and is suitable for different types of problems. The next, here we have training the model. The machine learning models are trained using the pre-processed data. Training involves presenting the model with input data along with the corresponding labels, allowing it to learn patterns and associations. Next, here we have building the model with voting classifier gives better accuracy. After training individual models, a voting classifier is constructed to combine their predictions. This ensemble method often results in improved accuracy by leveraging the strengths of multiple models. Then next here we have Flask framework with SQLite for sign up and sign in. This step involves integrating the machine learning model into a web application using the Flask framework. Additionally, SQLite is used for handling user sign up and sign in functionality. Then we have importing the packages. It is similar to the previous step where we have to upload the packages like NumPy, Pandas and Matplotlib. Then we have exploring the dataset. A second round of dataset exploration, likely in a different context or for a different purpose, to ensure the relevance and quality of the data throughout the project. Then we have data processing, count vectorizer. Further, data processing involving count vectorization, a technique to represent text data numerically, indicating a focus on text-related features. Then we have user gives input. So here in this, interaction with the application begins as users provide input, which could be in the form of text, preferences, or other relevant information. Then we have the given input is pre-processed for prediction. Pre-processing steps specific to the user input are applied to make it compatible with the model for the prediction. This might involve tokenization, vectorization, or other text processing techniques. Next, we have aspect extraction using LDA. LDA here stands for latent direct allocation, which is applied for aspect extraction. This technique helps to identify underlying topics or aspects within the text data, contributing to a more nuanced analysis. Then we have trained model is used for prediction. The pre-processed input is fed into the trained machine learning model to generate predictions or classifications. And the last one here we have final outcome is displayed through front end. The results of the model predictions, possibly along with additional information or visualizations, are presented to the user through the front end of the application, indicating and completing the user interaction loop. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. The next here we have static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Then here next we have with folder which is named as data. This folder contains of the dataset which is used in this project. Next here we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. The next here we have signup.db file. This file appears to the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So now here you can see that the link has been posted over here. Just copy this link and paste it into any of the browsers. Here I am using Chrome. So just paste the link over here and now hit the enter button. So here you can see that this is the home page for the sentiment analysis. For contacting them, you can enter your name, your phone number, your email ID, and your subject and the query over here which you want to contact by sending them, and click on send message. So here you can see that there is a button for sign up. Just click on it and enter your name, your mobile number, your email ID, and your password for doing the registration. I have already done the registration, so here I am clicking on sign in button. And now just enter the username and the password over here which you have created while doing the registration, and simply click on register button and click on OK. So here you can see by scrolling down below that it is asking for enter the message. So just let me enter the message over here. So now here you can see that I have entered the message over here, and now simply click on predict button. So here you can see by scrolling down below it is showing that the message which we have entered over here for the outcome as the sentiment of a product review is positive. So depending upon the message you are providing over there, it will showing the sentiment for that message, whether the message is positive, negative, or neutral. Here you can see the aspect extractor from the messages are aspect analysis, sentiment categories, attribute 1, data, text, base, and technique. So depending upon the message you're providing over there, it will be showing the sentiment of that message. Here you can see that there is a button for about. Just click on it, and here you can see that there are many different graphs which is showing the algorithms over there, and based upon the algorithms it is showing the accuracy of those algorithms. Here you can see that there is a button for sign out. By simply clicking on this button, you can successfully log out with this. So now coming back to the conclusion part. To sum up, the incorporation of machine learning into aspect level sentiment analysis for Amazon products represents a substantial advancement in enhancing our grasp of customer sentiments within the extensive pool of reviews. Utilizing machine learning algorithms facilitates a detailed scrutiny of product feedback, enabling the pinpointing of particular strengths and weaknesses across diverse aspects. This automation of sentiment analysis at a granular level empowers Amazon to effectively navigate and understand the varied opinions expressed by its customers. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.